We're back. Bones, welcome back, Bones. We're back, and today we're going to talk about air pressure. Okay? This is another atmospheric variable that people often overlook that really affects the weather outside and what we deal with on an everyday basis. So, here we go. This is what we're going to talk about atmospheric pressure. So, pressure is just the caused by the weight of the air pushing down on us. Okay? Yes, air actually has weight. That's why if you just blow up a balloon, okay, and you drop the balloon will fall because the air inside actually has mass to it. So there's air molecules, and the amount of air molecules in an area causes pressure. The more air molecules in an area, the higher the pressure. The less air molecules in the area, the lower the pressure. Now, when we're talking about air in an area, if when we take away air molecules, we have to replace it with something else. Okay? All right, Bones? So we can't just have empty space. It's not like a vacuum. It's not like outer space. Okay? So when we take air away from the area, we replace it with something. We replace it with water. So this is what causes high pressure and low pressure and the weather conditions that go along with it. So for example, if we have a lot of air in an area, okay, that is what's considered high pressure. All right? That means there's a lot of air bunched up really tight together. That means that there's no space for water. There's no space for water. So that means that the air is going to be very dry and very cold. Cold, dry weather are associated with high pressure. Okay, now cold is a relative term. It doesn't mean it's cold outside where you need to bundle up and have a hat. Okay, it just means cold to the relative season that we're in. Okay, or it could still be warm, but it's going to be dry. But we consider it cold weather because there's no moisture in the area. Okay, so we say it's cold and dry. So a way to remember this, the way I like to remember it, is because high pressure usually means that you're going to have nice weather, happy weather. Whenever you see a big H on a weather map when you're watching the weather in the morning, okay, that's a good sign that we're going to have nice, good weather. All right, so what I like to say is high pressure, happy weather, cold and dry. All right, say it with me, Bones. High pressure, happy weather, cold and dry. High pressure, happy weather, cold and dry. Say it over and over to yourself until it becomes stuck in your brain. I'm telling you, it's going to help you. It's going to help you on your upcoming tests. It's going to help you next year when you're in earth science. It's going to help you. High pressure, happy weather, cold and dry. Okay, now, when we have a low pressure system, low pressure means there's less air in the area, but that air has to be replaced with something. And as I said before, it gets replaced with water. Okay, so low pressure tends to bring in warm air. So the molecules are moving around and they spread out. They're moving around faster and they spread out, causing space that needs to be filled. And like I said, we fill it with water vapor. So we say that low pressure equals warm weather or lousy weather, warm and wet. Okay, low pressure, lousy weather, warm and wet. So if you see a big L on a weather map and it's over Long Island, it's over our area, you know you're probably going to get some rain. It's going to be a rainy day. Okay, so low pressure, lousy weather, warm and wet. Again, that word warm is still a relative term. So in the middle of the winter, when we say we have a low pressure system coming over us, it may be snowing out. Okay, so high pressure, happy weather, cold and dry. Low pressure, lousy weather, warm and wet. Low pressure, lousy weather, warm and wet. Say it over and over to yourself a million times until it gets stuck in your head. It's going to come up again. It's going to come up a lot. And this is something you can use in your everyday life when you're looking at a weather map. So if you see a high pressure area, okay, or a big H on a weather map in like Pennsylvania, we know that's going to start blowing towards us. We're probably going to have nice weather coming up. If we see a big L, kind of like in New Jersey, okay, we know that lousy weather, probably stormy weather, is going to be coming our direction very soon. So high pressure, happy weather, cold and dry. Low pressure, lousy weather, warm and wet. Okay, that involves with the amount of air in the area. Okay, so the more air in the area, okay, the less water. The less air in the area, the more water that has to be filled in there to make up for the lost space. All right. So now we measure this using something called a barometer. Okay, and a barometer is measured in millibars. Okay, a barometer it just looks like a fancy kind of thermometer. They're very similar, but it's a barometer because it measures atmospheric pressure. Now, the air pressure at sea level is considered 1,013.2 millibars. Okay, that's just the air pressure at sea level. And when that air pressure goes up, we know we're going to get nice weather, high pressure, happy weather, cold and dry. When that barometric pressure goes down below that, low pressure, lousy weather, warm and wet, we're probably going to get stormy weather. Now, when we look at this on a map, okay, we have these things called isobars. Isobars are lines on a weather map that connect equal areas of air pressure, just like we had isotherms. Isotherms connected equal areas of temperature. Contour lines or topographic lines did equal levels of elevation. Well, we have this thing called an isobar now, okay, which connects equal areas of air pressure. And this is how you remember it. You see the word bar in here, and we measure air pressure with a barometer. So BAR, BAR. They go together. So if you can remember that a air pressure is measured with a barometer, then you should be able to remember that on a weather map, equal areas of pressure are lined up with an isobar. Okay, barometer, isobar. The bars go together. So what does that look like? Here's a couple different barometers first. Here's an old school barometer where the more air pressure there is, it will push down on this mercury right here and push it up a tube, causing the air pressure to go up. But most often we see barometers that look something like this. And nowadays, these days and age, they're becoming digital on our phones. You can just look at the numbers digitally on any device that you have or any weather app that you have. This is what I'm talking about when I'm talking about what an isobar looks like. Notice, this should look very familiar. This looks like contour lines on a topographic map. This looks like isotherms on the weather map. Okay, this is what's known as isobars. So anything around this area here is going to have a pressure of about 1,000. Here is 1,004. The next one is 1,008, and so on. Notice we have an L here. Bones, do you remember what type of weather is associated with the letter L, or a low pressure system? Low pressure, lousy weather, warm and wet. Okay, so it's probably going to be stormy here because we have a low pressure system blowing through. All right, and if you notice, these numbers are smaller than the 1013.2 air pressure at sea level. So the air pressure is going down, therefore there's less air in the area, it gets filled with water instead, and you get stormy type of weather. Low pressure, lousy weather, warm and wet. Okay. Now, air pressure causes wind, or I should say differences in air pressure cause wind. Okay. Wind is nothing more than horizontal air movements. Air moves from over here to over here. All right. That's all it does. Now, just like diffusion, molecules don't like to be clumped up. They like to spread out. If you were in a classroom and I pushed you guys all into a corner, you'd be very uncomfortable. You would be elbowing each other. You'd be wanting to get out of the corner of the room. Okay, you'd want to spread out in the room. Just like if somebody were to take some perfume or some cologne and spray it, or some air freshener, spray it in the corner of a room, those molecules will eventually spread out throughout the room and you'll be able to smell it throughout the room. Same thing happens with wind. Air doesn't like to be tightly packed. So wind blows from an area of high pressure to an area of low pressure. Now, the higher the high and the lower the low, the faster the wind blows. Okay, so if you have a high pressure system and a low pressure system that are kind of close to each other, then I like to think of it as like a water slide. You're going to have a nice gentle slide down the slide. Okay. If you have a water slide that looks like this, a very high pressure to a very low pressure, you're going to go a lot faster down the water slide into the pool of water. So wind is simply when air moves from an area of high pressure to an area of low pressure across the ground. Okay. Now we measure this stuff with two things. We have something called a wind vane and an anemometer. A wind vane simply tells us which direction the wind is coming from. Okay, so oftentimes this is a wind vane right here. Okay, it just points in the direction the wind is coming from. Often they put like a little animal on there. You see them with roosters and chickens. This one happens to have a dog. Again, a wind vane tells you what direction the wind is coming from. On your devices, it will probably just have a little arrow or a compass that tells you which way it's coming from. An anemometer, okay, almost looks like a pinwheel that you win at a carnival where you blow into the pinwheel and it spins. Okay, the faster it spins, the faster it's recording the wind blowing. All right, so we have a wind vane and an anemometer, and we use those two things to determine, number one, what direction the wind is coming from, and number two, how fast the wind is blowing. All right, if you own a sailboat, if you're a boater, you have to really pay attention to this, especially if you like sailing. What direction the wind is coming from, how fast is it blowing, All of that stuff has to be considered, taken into consideration when you're out on the water. Now, there's this something called the Coriolis Effect, which affects which way the wind blows based on the Earth's rotation. And here's the only thing you have to remember, okay? Objects in the northern hemisphere will turn to the right. Okay, that's all you have to remember. They're going to turn to the right towards the equator. Objects in the southern hemisphere are going to turn to the left. So if you notice, they're both turning towards the equator. Okay, so objects in the northern hemisphere are going to turn to the right and go south. Objects in the southern hemisphere are going to turn to the left and start heading north to the equator. And that's what's known as the Coriolis Effect. This is because the air patterns are moving along with how the Earth is rotating, and it all comes together like that. Okay, so I hope you learned a lot with high pressure, happy weather, cold and dry, low pressure, lousy weather, warm and wet, because the amount of air pressure is the amount of air molecules in an area, which causes the wind to blow, because the air molecules don't like to be packed up together. So wind blows from an area of high pressure to an area of low pressure. All right, and that's what you need to know about air pressure and wind.